Okay, so once you get into Google Classroom, guys, okay, you are looking for, okay, the position versus time graph lab. So it actually even shows it here, okay, on the opening screen. If you just click on that, it'll open the task directly, okay. Your work here is the Google Doc. You'll want to have that open, okay. I'm going to be going over a bunch of the stuff to do with the lab. You'll want to make a few notes in your file, okay, pertaining to the variables and the hypothesis and stuff like that, okay. And then I'm going to give some instructions on how to perform the lab, gather your data. Once everyone has data, then I'll walk through a review of how to build the graph in Google Sheets in case you don't know how to do that or have forgotten. Okay, I will walk through that as well. And then whatever time is remaining, you have to assemble your report and do your calculations and whatever else. Okay, so that's where we'll be headed. Okay, this file here that says Graphing Lab Data 2018, it's a Google Sheet file. If you're here today, you don't need that. Okay, that's just because we have a few people who are absent for various reasons, and they're going to need that data to do their lab report because they're not here to collect data for themselves. You're going to have your own collected data to use instead. Okay, so you don't need to worry about that one. This file here, the PDF, is the lab sheet. It's what I'll be working off of while I give you the instructions. So it's what your guys' file looks like is, okay, it's basically just a blank template. You have to fill everything in on it. Okay, the thing I'm working off of, okay, has stuff filled in already, right? It's not the stuff you need to fill in, it's basically just the instructions for you for what to fill in, okay? But that's, okay, what that file is. In case you're wondering, what are all these files, what do I need them for? That's what you need them for, okay? Every lab we do will work the same way. You'll have a Google Doc that you're going to submit to me as your lab report, okay? There'll be a PDF file that is the lab instruction sheet. There'll most of the time be a data file, okay, that you can use if you're not here or your data sucks, okay? Sometimes that happens, but not often, and that kind of thing, just so you're aware. Okay, so the purpose of this lab is that we want to kind of hone our skills to do with position versus time graphs, right? So what we're going to do is we're going to gather data for a cart that is going to be traveling at a constant velocity along a track. Okay, we're going to graph that data on a position versus time graph, and then we're going to use that position versus time graph to calculate a few things that we're asked to calculate in the analysis. Okay, it really won't take you very long. The analysis is pretty straightforward. Okay, then you'll have your conclusion and your evaluation. Okay, so for the problem, okay, you need to put something in your own words here for the problem we're investigating. Okay, what we're trying to do is determine the speed of two toy carts using a position versus time graph. Okay, that's what we're trying to do in your own words. That's your problem. Okay, the design, we need to identify and explain. Key, explain your variables. Okay, you can't just go manipulate a variable as this and be done. You have to explain why it is. Okay, so we're going to go kind of through those a little bit here. As I describe the experiment, you should be able to figure out what things are manipulated, what things are responding, and what things are controlled. Some of them I will directly give away. Others you will have to figure out. Okay, that's why you have to listen carefully to get the ones I give away. All right. So here's how the experiment is going to work. We're going to put this cart onto one of these tracks. Okay, all of these tracks effectively work the same. Some are metal, some are wood, but they all work the same. Okay, they have grooves in them that are precisely spaced for the wheels of these carts. Okay, what we're going to do is we're going to run two different trials so that we get kind of two different velocities for the cart. Okay, so what we're going to do is you're going to have your phone with the SparkView app open. I haven't even got in how that's going to work yet, okay, but we'll get to that. Okay, you'll have that app open and you're going to be recording the data that the cart is going to transmit to you. So all you're going to do is start with the cart at one end of the track, and on the first trial, just give it a very light push. Okay, well, probably a little harder than that. Okay, but give it just a light push, okay, so that it can travel along the track a little ways. Okay, and that's really all we need to do. So again, I'm pushing it too lightly to give it kind of a push like that. Okay, it's not going to slow down too much, right? It's effectively going to be traveling at no, not gravity. Watch out for that. That happens if you press this little black button and you're not aware of it. Okay. It's not really all that important, but it will scare you just like it did me. Okay. All right. So all we're doing here, yes, obviously at the beginning of this, when I push it, what kind of motion is the object undergoing? It's accelerating just for that instant, and that's okay. We'll be able to tell that from the data. Okay, when you build the graph, you'll know what part of the graph is where you were accelerating it and what part of the graph was where you stopped it at the end. Okay, and we'll be able to take those parts off. Okay, we're only concerned with the part in the middle, okay, where it traveled at effectively a constant velocity. All right, everybody follow there. So your first trial, give it just a little push. Second trial, give it a bigger push, so it goes a little faster. Okay, that way you get two different lines on your graph. If you do it exactly the same twice in a row, your lines will overlap, right? And we're not looking for that. Okay, so the things we are recording here, and the things we record usually end up being our variables. Okay, we are recording the time that the cart travels and the position of the cart. Okay, those are the two things being recorded. Right? We're building a position versus time graph from that data. Now, what variable, manipulated, responding, or controlled, always goes on the x-axis? Time. Which variable, manipulated, responding, or controlled, goes on the x-axis? Manipulated variable. Okay, so you were listening, you might have caught that one. Okay, time is going to go on the x-axis. You're welcome. I didn't have any choice. But that's okay. Okay, I was going to give it to you anyway. So that one goes there. Okay, we need to explain though. Okay, why time ends up being the manipulated variable. Okay, here's the reasoning. You need to put this in your own words. Kind of a freebie here. Okay, but because I start the cart and I stop the cart, do I determine the length of the experiment? That's how I manipulate time. I'm not making time run faster, slower, or sideways. Okay? I'm just determining how long the experiment can run for. In that way, time is manipulated by me. Okay? The experimenter. Okay. Now, remember, you have to have a responding variable, which I think you can figure out, and you need to have 3 controlled variables. When you explain your controlled variables, I need to hear the following things: how it's being controlled and why it's being controlled. Okay? In other words, what effect would it have on the experiment if this thing didn't stay constant? All right? So you kind of need to look at your setup and look at some things in the setup that need to stay constant throughout the experiment. I'm going to give you one of them. It's really important. Okay? In this experiment, we need to make sure our carts are traveling at a constant what? Velocity. Otherwise, it's really not an experiment about constant velocity. You need to come up with 2 more. Okay? Things about this setup that are going to stay the same throughout the entire movement of the cart that could otherwise affect the shape of our position versus time graph. Okay? Basically, anything that could affect the speed of the cart while it rolls needs to be controlled. Okay? If it isn't, then the cart will either speed up or slow down. Okay? So anything that could cause the cart to speed up or slow down while it's supposed to be traveling at a constant velocity would need to be controlled. All right? So you got to come up with 2 things. For our hypothesis, what 3 words need to go in a hypothesis? If, and, then. Okay? Those are the 3 parts of a hypothesis. The if part is your premise. Okay? That is what you think is true or what is causing things to happen. The and part gives a brief description of the experiment, and the then part gives me what your expected findings are. Okay? For this experiment, okay, the if part, okay, should talk about, sorry, I want to say this the right way so I'm not giving it away. It should talk about the type of relationship between position and time for an object traveling at a constant speed. Okay, and by that, I mean, is it a linear or exponential or inverse or quadratic or polynomial type of relationship? Okay, that's what I'm looking for there. Okay, what kind of relationship do position and time have for an object traveling at a constant velocity? The and part simply describes the experiment. A cart is being allowed to travel at a constant velocity with its position and time being recorded. Something, that's what we're doing. Okay? The then part of your hypothesis needs to answer this. Okay? How are you going to calculate velocity from your graph? Okay, and be specific here. From the graph, not your data. From your graph. Okay, you need to calculate the velocity of the object using only your graph, not the long table of data that you're going to get.
So for the hypothesis, other teachers have had it like if then because. Do we have to state the because in our hypothesis? Like
You can if you want to. I mean, sometimes because naturally goes in with then, but that's entirely up to you. Yeah. All right, so procedure is going to work like this. Okay, kind of explained it to you already. The cart is going to be placed on the ramp. Okay, one person in your group is going to be using the SparkView app on their phone to record the data. Okay, now I'm going to show you how that works here in just a minute. Okay, but remember, all you need to do is time this so that you're starting the data collection when the cart is pushed and stopping it when the cart stops. Okay, everybody clear on that? Now, I demonstrated this on top of a desk. You are not to perform this experiment on top of the desk for a couple of reasons. The desks are not level. That might help you with a control variable. Okay? And if people aren't paying attention, one of these $600 carts will fall to the ground and break. And I will be displeased. So, make sure you put the track on the ground, please. Okay? If it goes off the end of the track and it's already on the floor, it won't break. Okay? Do not want these broken.
Isn't the floor also not covered?
Well, it's close enough. It's the best thing we have. Okay? If you really wanted to get nitpicky, you could throw your phone on the track and put the leveling app on there and get the corners perfect. But yeah, we don't really have that kind of time. Okay? I'm not gonna make that big a deal. But the desks are significantly not level. They're all twisted and terrible. Okay? I mean, we set this on and it starts to roll on its own, right? Like it's definitely not level. Okay? All right. For the analysis part of this, so once we have all of our data, okay, the app will actually allow you to share that through Google Drive with everybody in your group. Okay, so everybody will have the data sent to them electronically, and then we will build position versus time graph for that data, which I will show you how to do. Okay, then using the spreadsheet, okay, or using the graph, okay, you are going to show this, and then using y equals mx plus b, determine the velocity of the two runs. It's not two different cars, it's just two different runs. Okay, then for your conclusion, copy and paste your hypothesis, and then explain to me whether the data you got supported your hypothesis. Were you able to calculate velocity using the graph in the way you stated in your hypothesis? Can you accept your hypothesis or not? Okay, that's what I'm looking for there. So a restatement of the hypothesis and an explanation. The explanation needs to be more than I was right. Okay, I don't want to see that. Okay, I want to see this is what the graph showed. The graph showed this kind of a relationship. Using this graph in this way, the group was able to calculate velocity, and here's why, and talk about that kind of stuff. Your conclusion should be a few sentences for sure. Okay? And then in the evaluation, you need to identify any sources of error, so anything that could have contributed to errors in measurement beyond human error, okay, and how you could fix those. Okay, and we already mentioned, okay, one thing that could be possible here. Your controlled variables are always a good place to look for sources of error. Okay, we do our best to control everything, but inevitably there's things that are beyond our control that could end up being sources of error. Okay. All right. Any other questions on that?